Hello, and welcome to our webinar, Configuring Real-Time and Big Data Workflows using ArcGIS. My name is Scott Ward. My colleagues Julia Bayer, John Fry, and I will be your hosts. First, I'd like to cover some administrative details. You can ask questions through the questions module, and we will answer those questions at the end. The recording for this webinar will be posted early next week if you'd like to review it in the future. With that, we'll get started, and I'll hand this off to John Fry.
Thank you, Scott. Welcome to the Configuring Real-Time and Big Data Workflows using ArcGIS. GIS provides a framework and process for decision-making. It senses, understands, and informs us how to respond. Sensing through measurements, geographic measurements, we see through visualization and mapping, we model the relationships and patterns, make projections, interpret things holistically, and then plan, design, make better decisions, and take part. Then we can repeat. WebGIS actually can integrate anything through dynamic linking. Everything on the web through visual overlays, like mashups. And we can distribute that through spatial analysis, bringing content in from multiple places, then doing modeling to understand our world. ArcGIS integrates many types of data to help solve today's problems, whether unstructured data, imagery, 3D, or more pertinent for this webcast, real-time data. ArcGIS provides us the framework for decision-making. Here is Esri's real-time visualization and analytics offerings, allowing users to integrate various sensor networks and IoT devices. You may be familiar with real-time and big data capabilities of ArcGIS Enterprise, where GeoEvent and Geoanalytics Server are the two primary products that allow us to bring in and analyze large data streams. ArcGIS Velocity is a new offering on ArcGIS Online that allows GeoEvent and Geoanalytics to work in the web, but as a software as a service component. It's estimated that roughly 80% of sensor data has a location component, which means there's a growing variety of geospatial use cases in the Internet of Things. And for example, data from sensors about employees can be combined with information about the immediate environment to help keep them safe, such as when they're in bad weather. More broadly, organizations want to monitor, manage, and optimize their assets, whether it's a fleet of vehicles or valuable hospital equipment, or for today, tracking assets in support of the COVID relief effort. The utility space has SCADA integration and operations monitoring, and the agricultural and environmental markets, there's crop monitoring and air quality monitoring as well. And in the transportation sector, there's an increasing number of roadway sensors and vehicles that are pushing their positions as well. So when we're talking about real-time GIS, what are we actually talking about? So we roughly break these down into three different types of observational data. There's stationary sensors, such as water gauges, weather stations, things that don't really move, but are updating constantly over time. And then there's things that move, such as cell phones, airplanes, vehicles, ships, satellites, trains, people, things that are constantly moving over time and reporting their position. And then there's things that happen. So intelligence reports, crimes, lightning, accidents, tweets, for instance. And then when you have this large amount of data, what do we do with it? Have you ever opened up ArcGIS Pro or another application? You have a big blob, a blue mass here. What is this data? We don't really know what it is, but we need a framework to process this data. We may need to bring in some other data as well, such as looking at there's zip code information from New York City, and then overlaying and understanding what's going on. This is actually taxi cab pickup and drop off data. And we're seeing in the bottom right here is blue is identified by larger amounts of pickups and drop offs. So upper northeast is LaGuardia Airport, having a large amount of drop offs and pickups, and the Central Park, being the central part of Manhattan, has a lot of pickups. Now we understand that from that big blue mess, we understand where taxi cabs are going and picking up and dropping off people. So here's more of a systematic view of our enterprise as it relates to real-time big data capabilities. So data gets ingested from different APIs and sensors. GeoEvent runs the ingestion. You can run real-time analytics, such as when something moves into a geofence, and be alerting when that happens. We want to visualize the data. We could store it as feature services, which drive different dashboards, or stream services, which are pushed to clients. So those are more I need something rapidly updating, push to my client. We want to store this information in the spatiotemporal big data store to allow us for quick retrieval of that large amount of data. And then once that data is stored, we can use Geoanalytics with the processing power to process large amounts of data. We could also work with ArcGIS Pro to use some of the big data analytics tools in the Spark framework that are running as GP tools in Pro. I'll show an example of that. And ArcGIS Online, which has ArcGIS Velocity, which is the full gamut of ingestion, real-time analytics, alerting, and storage, and big data analytics. And that's a software as a service component with ArcGIS Online. So what we're going to do is we're going to focus today on one workflow from a feed provider to ingestion with ArcGIS Server to storage and then running big data analytics. But we're going to focus on a one real life workflow, try to understand a pattern of life of fishing vessels and understanding where transshipping occurs. So the Food and Agriculture Organization estimates about 15% of the fish in the world are illegally caught, and that usually involves what happens with transshipping. So you have some illegally caught fish mixed with the legally caught fish, and then that goes to market. And what transshipping also has been identified with kind of a modern day slavery where crews are going back and forth between different ships. It's hard to track their welfare and their being. So what we're going to do here is we're going to use GeoEvent to keep track of where the vessels are, get some alerts when we're moving in and out of areas. We're going to start storing some of that vessel record so we can go back and see where they've been over time, seeing where vessel density is the highest, and then identifying where transshipping occurs through geoanalytics, whether vessels come very close to each other, and then identifying some patterns of light which vessels are actually fishing versus transiting. So as it applies to AIS data, the International Maritime Organization requires ships to have an automatic identification system, or AIS, on board their vessel. So that information is provided to a satellite or terrestrial receiver. And we're using an organization called Spire, who has a satellite constellation that tracks AIS data. So what we're going to do is we're going to get to their API, ingest that into GeoEvent, run some real-time analytics, and get alerts when vessels move into certain areas. We're going to visualize the information in dashboards. We're going to store that information in the spatio-temporal big data store and run some big data analytics on ArcGIS Pro. Also use Geoanalytics Server to run some analytics in the web, as well as more of a data science role where we're using some of the tools in the Python API. And then finally, we're going to show ArcGIS Velocity doing ingestion to big data analytics. And first, we're just going to kick it off with a demo about ArcGIS GeoEvent Server. So in this demo, I'm going to do some vessel tracking, alerting, and storage of the data.
Hey, we're going to start out at Spire's website. So this is going to be an API we're going to subscribe to in GeoEvent to get ship position information. A lot of organizations have APIs. Some are well documented and some are lacking, but this one's a really good one because it tells you what the data is, what the format it's in, and gives you some examples from GitHub. So you can use that in Postman, an application we'll see in a minute here. So as we go down, we can kind of see the what's in each request, and an example how to do the request. And you're going to need that because you're going to have to understand how GeoEvent will subscribe to the data. I'm in Postman here, and there are a few examples of requests that were provided by Spire. The reason why I show this is that when I'm testing, I like to use Postman to kind of get an understanding of how the data is coming in. So what I've done here is I've requested from their API and then get returned some ship position information. This will help me define my GeoEvent definition, which is basically the schema from your ingestion of the API to the GeoEvent service. So now we're in GeoEvent, and each section is broken out into inputs, such as subscribing to different APIs, or outputs, such as updating a feature service. And GeoEvent service is kind of the glue that puts them together. So we have our inputs, we're doing stuff like filtering or processing, and then we're outputting at different outputs. So in the green here is I'm actually connecting to that Spire API. I have the URL, tell it to create a GeoEvent definition or not, and then I basically will tell like what part of the API to connect to, what object, and doing the data object. And now we have some field mapping, we have some filtering out of bad positions, and then I like to create geometry. So say if the information is in a lat long, you can make that into a geometry using the field calculator. And in the right here, I have an output these are two big data store outputs, and we'll see that in a moment in the next app, but how can we analyze those? And I'm also filtering for an area of interest. So this area is around Mozambique and Port of Maputo, and I want to know the vessels in and out of that area. And I'm starting an incident detector. So when a vessel enters that, I want to keep track of it, but I also want to get an email sent when it enters that area. So here's an HTML email I've created. So when a vessel moves in, I get an email. GeoEvent powers different dashboards like this. Here's an example of a maritime domain awareness dashboard of an area around the port of Maputo in Mozambique. So we want to be kept aware of vessels moving in and out of this area. So on the left-hand side, we have a geofence of how many vessels have reported positions in this area. We're also broken out by which vessels have started. So we're using the incident detector to get information about what vessels have entered the area. As we zoom in, we get to see the different vessels. We see green vessels who have entered the area, yellow vessels which are ongoing, vessels in purple which have left the area, and vessels in blue which have left the area a long time ago. In GeoEvent, I'm keying off the vessels that have entered the area, and I want to get an email when that happens. So as we transition over to our email, I'm getting some information about that vessel that has entered that area. GeoEvent is also giving us the understanding of what vessels are ongoing in the area. Some of these vessels are spending a long time in this area. Some of them could be fishing, but some of them can be dwelling, which could be a maritime vessel of interest. And finally, some of the vessels are indicated by pink, which indicates they have left the AOI, and that's our last reported position in the AOI. In this dashboard, we've seen how GeoEvent allows us to keep track of shipping in an area of interest. We've seen how we can get alerted when vessels are entering the AOI and keeping track of how long they've spent in there. Next, we're going to transition over to how we can visualize the big data that GeoEvent is pushing off to the spatiotemporal big data store. Now, working with the big data store, you might want to use an application like this. So think of this as one you would analyze or look at the data that's been collected. So here's the big data store of all the ship positions over the last few weeks. You have the darker red areas are the ones that have higher counts of vessels. And as we zoom in, it's going to update on the fly. So you have different ports that show up. And then if you're interested in this area out here, the white ones are actually the last update of different vessels. So there's actually a lot of vessels out in this part of the ocean. We can click the time slider and play it over time. So that's a live binning process. We can see how the vessel is accumulated over time, and you can play it back and forth. So let's go and run some queries on this data. So I think maybe I want to look at different vessels of interest, whether they are moving slow in this area. So this could be a vessel that's transshipping with another vessel, or a vessel that's kind of like a refrigerated vessel and basically taking all the fish up and trying to get them to market. All right, so let's see anything between 0 and 2 knots in this area. So there are quite a few actually. So these are vessels that have reported those slow amounts of speed. We could take a look at the vessel identification and run another query to see where it's been over the last few weeks. So put that information in the MIMSI, and it's going to search. Okay, it's been in pretty much this area, back and forth, doing some fishing in that area. And then we can then see the individual reports of the vessels when they came in, what their speed were, and what flag and other details about that. So next thing we want to do is run a selection on this area. So if we wanted to select the data, we've done some brief analysis and querying it out. We may want to use a different application to select the data, maybe use ArcGIS Pro to run some further analysis to find out what's going on in this area, whether any of these are overfishing or bad actors or transshipping. So we go ahead and select our area here, and that's going to give all the features in this historic AIS dataset. And then we can export it out to another application like ArcGIS Pro. What we have shown here is how GeoEvent can subscribe to feeds, run some analytics, and send the data to be stored.
All right. So what we've seen here is let's take a look at the GeoEvent in action, how we can do from an API and get alerts from vessels. So we showed that, but how are we going to, let's go in a deeper dive into what GeoEvent was and just recap what we've seen. So the first capability of GeoEvent is ingestion of the data. So we're able to connect to that Spire API and bring that data into our system. So the data comes in. Next thing we want to do is run the next capability, which is filtering. So some of the records and APIs they might be bad data. So they're reporting 0, positions. I don't want those data. So what we did was use a filter to pass the information with records forward. And in this example here, it's showing that, that it's filtering the blue and orange. So if it's not blue or orange in this example, they're going to be dropped. Next is doing filtering through spatial relationships. So geofencing. So I had an area around Maputo and Mozambique. So areas inside that will get an alert. We're using incident detector, but if we had a geofence up, the information in there will be saved or alerted in our case. We could do other relationships between points and lines and polygons as well. Next capability is processing. So you can run tools like the incident detector or geotagger, or in this case, use a buffer. And then how do you want to store the data? So we could store it as updating a featured service in just a regular geodatabase. And the next is storing the information in a spatio-temporal big data store. So what we did was 2 outputs were in that spatio-temporal big data store that had that binning process. So an app that I can go and request, hey, where has this vessel been over time? And we didn't really hit on this. The stream services are really for something that's updating quite frequently. Stream services are pushed to the client. So for instance, you connect to an API and you want to push that information as well. And then we did some notifications through when vessels were entering an area that send me an email. And something we didn't hit on is the ability to adjust behavior in the IoT. So connecting to Amazon or Azure and be able to actuate different devices as well. So the next section we're going to move on is to looking at how to analyze some of that stored data. So I'm going to turn over to my colleague, Julia.
Thanks, John. So with that, I'm going to switch over and talk about Geoanalytics Desktop, which is a capability to process big data within ArcGIS Pro. Geoanalytics relies on Apache Spark and parallel processing to analyze large amounts of data. So being able to take large amounts of data, run tools within the desktop environment, and understand trends and patterns we're seeing. So here, breaking down taxi cabs at a census tract level or visualizing patterns over the country as a whole. Geoanalytics is available through both the desktop environment, so starting with ArcGIS Pro 2.4, having the desktop tools available with an advanced license, as well as through Geoanalytics Server, and using the tools in Map Viewer, the REST API, or the API for Python. And so with that, I wanted to talk a bit about when to use desktop versus server for Geoanalytics. You tend to use Geoanalytics Server with big data analysis and processing. So if you have multiple servers that you want to utilize, you want to bring the power of big data analysis to your entire organization through a WebGIS framework using the tools available through the Geoanalytics Server, versus using Geoanalytics Desktop for more local data and testing. So if you have local data from file databases or something on your own computer that you want to process, not as large as something you would use within the server, as well as for prototyping. So using your workflows within desktop before bringing them out and sharing it out through Geoanalytics Server. And I wanted to talk a bit about the tools available for Geoanalytics across all of our different clients, whether in Map Viewer, ArcGIS Pro, the REST API, the Python API. They're quite similar in what they can do and the capabilities. One tool I did want to highlight starting at 10.8.1 within Geoanalytics Server is the geographically weighted regression and using some of our more spatial statistics models to work on your big data. And with that, I'm going to jump into a demonstration focused on big data analytics within ArcGIS Pro. Jumping into ArcGIS Pro, I have a project focused on the coast of Ecuador in Peru. In this demonstration, there are almost 1 million points representing ship locations in this area over the course of 7 days. With a massive amount of data, it's hard to discern meaningful trends and patterns, and that's where the geoanalytics tools in ArcGIS Pro come into play. These tools are made with Apache Spark to process large volumes of data quickly through parallel processing. To investigate this area of interest, I'm going to calculate a density of ship locations. Because I've run this tool before, I can get to it by opening up my history. I'm going to visualize the density of ships within 20 nautical miles and visualize it as a hex bin within my map. Since this is time-enabled data, I can explore patterns over both space and time. As we might expect along the coast and in ports and in the Galapagos Islands, there's a high density of ships. But in the open ocean, it could be a potential indication of transshipment. Now that we've identified a potential area of interest, we can investigate further using find dwell locations. In this case, we're looking to see if ships are dwelling for over 6 hours within 500 meters of each other. And turning on the output layer, we see that in the same location, ships are indeed dwelling for a prolonged period of time. With ArcGIS Pro, we also have movement tools as part of the intelligence toolbox. These tools are built with Apache Spark to process large volumes of data. Here we're using the Find Meeting Locations tool to see where ships are meeting up, in this case within 1 nautical mile for at least 5 minutes. Viewing the output, we see ships meeting up frequently at port or in the Galapagos, which isn't a cause for concern. But the meetings occurring up further offshore are an indication of illegal activity, potentially. In this scenario, we looked at almost 1 million specific points and were able to understand potential areas of concern. Geoanalytics enables you to process large amounts of data much quicker through the use of Apache Spark. One tool that John will highlight in his demonstration is the Reconstruct Tracks tool. Here it took 34 seconds to run, indicating the power of geoanalytics to make sense of large volumes of data. And with that, I'm going to pass it over to John to talk about geoanalytics within their enterprise environment.
All right, so we showed, just to recap, we showed how data was coming in through GeoEvent. We showed how we could store it as a spatiotemporal data store, and we showed how we can get access to that data and export it out to analysis such as Geoanalytics Desktop tool. So now we're going to take it a little bit further and start working with Geoanalytics Server. So Geoanalytics Server is if you want to scale out your operation with your Geoanalytics Desktop tools, or just do some pass it off the enterprise power to different user types, whether they're a GIS user, an analyst that just needs to use it in a web map, or for a data science specialist that needs to write some custom tools using that framework of geoanalytics. So what types of data can I analyze and from where? So Geoanalytics Server, one of the main differences is using a lot of your enterprise data on your portal. It works really well with ArcGIS GeoEvent Server to get at that spatiotemporal big data store and start analyzing all that data. We can connect in other business systems and data stored in Hive or HDFS and some file structures as well, and then connect into Azure and Amazon Cloud Stores as well. So here's more of a process flow of how that would work. So Geoanalytics Server is in the beginning or in the middle here, and in the beginning in the GIS data, you could use some of your enterprise data on your portal, whether they're hosted feature layers or feature services as well, or inputs like Amazon S3 or Azure Blob Storage. or some of those other file structures. So bringing that enterprise data, and on the right here is outputting that information. We'll run some tools that will write back to the hosted feature layers on our portal. We can also output to different other mechanisms such as S3 and Azure. One of the other capabilities, Geoanalytics Server does support sort of that GIS user or non-GIS user when they want some tools in the web really quickly, but it also supports more of that data scientist or developer where you have the ability to run some custom Python scripts using that framework, using a tool called the run Python script task with Geoanalytics. So I'll turn it over to a demo here. What we're going to show is how to use Geoanalytics in the web using very an analyst kind of workflow, and then using the Python API with some Jupyter notebooks that are built into our portal.
Let's take a look at how we can quickly use Geoanalytics Server tools to begin to analyze data right in the web map. Analysts can begin to understand patterns in their large enterprise data, and in this case, beginning to understand the pattern of life of fishing vessels in this part of the ocean. In this web map, we have our Spire ship position data, and we can begin analyzing it to see what vessels are actively fishing. To access the Geoanalytics tools, we click Analysis and see the two types of tools. There's the standard portal tools and then the ones that are powered by the Geoanalytics server. The Geoanalytics server tools are broken into broad groupings. What we're going to do is we're going to run a reconstruct tracks tool, which will identify those that are fishing versus those that are transiting. We'll choose the data and set the ID of each vessel, or the MIMSI, and then set some statistics to be run on the data. We'll choose the speed mean and the course standard deviation. Let's go ahead and save our data. And one thing to note here, I do have the use current map extent chosen. This will basically subset the analysis to this map, so you won't do it over the entire data set, over the entire world. And this tool will take a little bit of time to run, but when we're finished, we'll get lines indicating the movement of the vessel. And there we go, there's our analysis with our track data. Now what this analysis did was it took the identification of the vessel, that MMSI number, and the time, and sequentially made lines out of that data. This could be very useful if you need to do overlays where there's no point position data, and you need to understand whether they're across a certain area. One interesting thing we could do with this is change the symbology to a relationship mapping style. And by setting this mean, speed, and course standard deviation, we get a visual depiction of those vessels that are actively fishing or moving through an area. Relationship maps are an easy way to visualize and compare multiple attributes in your web map. These allow you to explore the relationship between two topics within a single map to see whether they're related. And in this case, we can identify fishing vessels very easily. Fishing vessels will have lower speeds and a high course standard deviation as they're moving back and forth across the fishing grounds. And then just transiting vessels will have high speed and low course standard deviation. So think about cargo vessels or tankers that are trying to get to the market as quickly as possible. This vessel has a fairly high speed and a low standard deviation of course. It looks like it's just transiting in this area and not having to do with any fishing. When we zoom in, we get a better understanding of the vessels that are actively fishing. With our track analysis data and the symbology that we have set, we see in orange the ones that are actively fishing. So these are the ones with very low speed and a very high standard deviation of course. Now we have a picture of those actively fishing versus transiting. We can also run tools like joins to find where two vessels have come close over the same time period. As we look around, there are a number of joins. Joins identify two vessels that were within the same time and space together. We can further identify the vessel and what time it interacted with another vessel and do some further analysis, whether it's a bad actor or not. We're not sure if these are bad actors, but they do have some Afghanistan flags. We have to do some further research to realize if these are actually Afghani flagged vessels or if someone just put that as a flag of convenience. In this map, we showed how an analyst can quickly use geoanalytics on enterprise data. That sees some more advanced capability where a data scientist could use the Geoanalytics Spark framework to run custom Python scripts. Esri's Python API has some great examples, and this website shows an example of how the Geoanalytics server tools can be run from a Jupyter notebook. You can download this and use this example, and it shows how to call your GIS, describe the data, and run some out-of-the-box geoanalytics tools. These are some of the tools that analyze patterns like aggregation of points and calculating densities. These are some of the services available with a Geoanalytics server. There's a tool that can take processing data further. We can use the framework of geoanalytics and then run custom Python scripts to up the processing power. And here's a brief tutorial how to use the run Python script task. This one uses a Spark tool that does a k-means statistical analysis, making statistical significant clusters of the data. And I've used this page as a tutorial, and I've gone to my portal and I adapted the script to work with my shipping data. Here's the notebook item in my portal. When we open the notebook, we have some explanation about what this does, and then we have some cells about importing the necessary tools, connecting to our ArcGIS Enterprise organization, and beginning the search for the data that we need. There's a cell here which allows you to search for some data, but better yet, there's an add-in tab that allows us to interactively search our portal and bring that into a cell, which is very useful. So there's our data that we're going to use. We then can initialize it, and then we'll start adding it to the map. Yep, there's our map called, and let's go ahead and add it to our map. All right, there's our shipping data. So let's check this data out and begin analyzing it. And then down here, we'll initialize the k-means libraries and start executing it. K-means is one of the most commonly used clustering algorithms that clusters the data points into a predefined number of clusters. Spark has this library, so I decided to just use this in this analysis to understand where are the significant clusters of vessels in this area. I've already run the tool here. It took about 45 seconds, and we can go add the output to the map. We can now see the k-means analysis for this product. And planners, we could do this to allocate resources to patrol different areas or task data collection assets like satellites to help in identifying illegal fishing in these areas. In conclusion, geoanalytics can help analysts in big data processing in the web map and also be able to support data scientists in their workflows using Python API.
All right, we're going to change it over to Julia, who's going to show ArcGIS Velocity.
Yeah, thank you, John. And so with that, I'm going to transition to talking about ArcGIS Velocity, which is an application within ArcGIS Online to do real-time and big data workflows. And ArcGIS Velocity is built with the capabilities of GeoEvent and Geoanalytics in mind, but being able to do these workflows that before would have required on-premise technology and using that within the cloud within ArcGIS Online. And to that extent, it's a really guided and configurable user experience. You don't need development skills or to host your own infrastructure and IT management. It's all hosted through Esri, and Esri and ArcGIS Online are controlling the scaling as well. And just to give a bit of an overview of Velocity, comparing it to GeoEvent and Geoanalytics in terms of the terminology, within Velocity, we have an item called a feed. This is similar to a GeoEvent server input, which John showed, so being able to ingest and visualize data. The analysis and alerting capabilities that we would have done before through a GeoEvent service, we can now do through a real-time analytic. And then finally, getting into our big data capabilities and using a tool or a script within Geoanalytics within Velocity, we call it big data analytic. And just like within GeoEvent and Geoanalytics, we have the same capabilities for Velocity. So starting with ingesting and visualizing our data, using geofencing and incident detection, doing alerting, as well as trend analysis, and doing this across all different sectors, whether within agriculture or transportation or security, being able to do that through ArcGIS Velocity as a cloud-hosted solution. And with that, I'm going to transition to a demonstration focused on maritime analysis using ArcGIS Velocity. This dashboard shows us the real-time location of Coast Guard vessels. When we click on a specific vessel, we can see how far it is from its home port. This information is being brought in using ArcGIS Velocity as a feed as well as a real-time analytic to determine the distance as each vessel travels. ArcGIS Velocity is a real-time and big data application for ArcGIS Online. It has three main capabilities: creating feeds, real-time analytics, and big data analytics. Feeds are commonly used to bring in information from third-party applications, IoT, or messaging platforms. In this feed, we're connecting to the Spire API to get information on ship positions, and Velocity automatically picks up the schema, although you can change field types or field names and add and drop fields. Next, you select the appropriate spatial reference information, in this case latitude and longitude, in the coordinate system. Choose a date and time, as well as a tracking ID. You can choose to pull your feed periodically, as we have here, every 5 minutes, or at a recurring time. Once the feed is created, you can view it as a new item within the application, ArcGIS Online, and open it in Map Viewer to see this information being streamed in. The next capability of ArcGIS Velocity is a real-time analytic. With this real-time analytic, we're bringing in our ship positions, as well as which Coast Guard district they're currently in, and doing a join to understand that spatial relationship. We're also joining each vessel with its Coast Guard home port to see how far it is using the Calculate Distance tool. There's a variety of tools within ArcGIS Velocity to analyze our data, as well as generate outputs as a feature layer, a stream layer, or an email notification. The final capability of ArcGIS Velocity are big data analytics. Here, our big data analytic is helping us determine where illegal fishing is occurring, bringing in our Spire APIs and using the tools to calculate journeys, dwell locations, clustering, as well as locations where ships are potentially meeting up, and then outputting these into feature layers. This is the same workflow we did within GeoEvent and Geoanalytics, but here we're doing it all within ArcGIS Online. This area near Japan has been identified as a potential area for transshipping. With Velocity, each of these new feature layers have been added to our ArcGIS Online, and we can visualize journeys, dwell locations, as well as locations of potential transshipping. With that, I also want to include our references we used for this scenario here. We also encourage everyone, this is coming up in less than a month, to attend our Esri Federal GIS Conference. We'll have more workshops on real-time big data and other capabilities and products within the platform.
Well, thank you for joining us. I hope you've enjoyed our webinar, and we will see you at one of our next ones. Thank you. Bye.